homework that was due for today. So if you haven't yet done that, please get it out right now and get it turned in. Okay, and one of the things that I wanted to go over today was adding fractions. Okay, so you're just going to have to find an empty seat, sweetie. Okay. So yesterday we talked about adding and subtracting fractions, and I had assumed incorrectly that we had a lot more experience with this than we actually did for some of us. Okay, because when I started seeing kids adding and subtracting fractions and using the easiest common denominator on all of them rather than just finding the least common denominator. Okay, so I completely skipped over the lesson that teachers would normally do if you understood what least common denominator is. So I'm just going to review over that, and then we'll talk about adding and subtracting mixed numbers. Okay, so what I mean by least common denominators is when you have a denominator pair and one of the denominators is already a factor of the other denominator. So is 3 a factor of 6? Yes. We know that 2 times 3 will give us 6. So in this case, do we need to change both denominators? No, I just assumed that you guys knew that. So I went ahead and just taught you how to deal with this kind of a fraction where the 7 and the 8 have they are not common factors at all. They have no factors in common, right? So, but these ones that have factors in common.
Lance Allen, please go to Mrs. Jensen's room.
Ooh, I hope he's not in trouble. Okay, so those two denominators have the common factor of 3. So we're just going to do this. Please watch. All right, so 2/3 can be multiplied by 3.
2.
Yeah, 2/2. I don't know why it's moving when I'm writing. Maybe, I don't know, I'm doing something wrong, I don't know. So do we have to change the 5/6 at all?
No.
Not at all, because that factor is already a 6. 2 times 2 is 4. 2 times 3 is 6. And then we have the fraction 4/6 plus 5/6 equals 9/6. Okay, a group of 6 will fit into 9 once, and you have 3 6 left over. Someone needs to mute, and that is the same as 1 1/2. So hopefully that's what you got for your answer for number 1. Okay, if you would have done it the way I showed you guys how to do it using the easiest common denominators, you would have multiplied this side by 6/6, this side by 3/3, right? According to our notes. And you would have 12/18. And then you'd have 15/18. Would I still get the same answer eventually? Absolutely. I would get, what would these two numbers be added together, 12 and 15? Okay, how many groups of 18 will go into 27? 1. And then how many leftovers would there be? What is 27 minus 18? 9, right? So that would be the same as 1 1/2. Okay? So literally, you could have done it using the easiest common denominator, and that would have been just fine. Okay? But if you use the least common denominator, you're saving yourself some time simplifying, and you will definitely over time save yourself having to multiply giant numbers together or even divide giant numbers. Okay, so with that being said, on this right here problem, is 7 a factor of 14?
Yes, I do.
Yes, and if you know your multiplication chart really well, you would see that right away, right? So you would know that on this side, this is the only one I have to change. This would be 10/14, and now I have the same denominator, a common denominator to the other one, and my answer would be 3/14. Okay? Whereas if you did the easiest common denominator method that we talked about in our notes yesterday, you would get a much bigger answer because you'd be multiplying 5/7 times 14/14. And then you'd be multiplying 7/14 by 7/7. Okay? So, that being said, please pay attention to our denominators. If your denominators are factors of one another in any way, you can usually just have to fix or change one of the fractions to its equivalent fraction with a common denominator. Okay, does that make sense? So we're going to keep going. All right. Can't figure out how to get out of here now. There we go. Google Slides. Yeah, I seem to have a problem here. Like, I'm not sure where it is, and I'm not sure if it's better to open it.
Whoa.
I think I'll open it from my Meet. Hi, you're talking again. You don't need to help them. He's a big one. Okay, so if you have your notes open, you can see that adding and subtracting mixed numbers, very, very similar to adding, subtracting regular fractions, okay? The thing that you don't have to do when you add and subtract mixed numbers is change them into improper fractions. The rule for multiplying and dividing fractions is to change them into improper fractions. We do not have to do that when we are adding and subtracting fractions. So get your notes out for me, please. Okay? Those notes that you've been writing on, where am I going to find those? Okay. I think everybody in my class has them out, and it's taken me an eon to get this opened. Okay. So I'm going to ask you to jump way forward in those notes. Okay. As a matter of fact, I think what I'm looking for is on the very last slide in your notes. It looks like this. Okay, so the big picture with fractions is right here in this checkbox. We have spent 2 weeks on multiplying and dividing fractions earlier this year. And when we did that, did we have to have common denominators to get started for multiplying and dividing? No, we didn't. We have to do that for adding and subtracting. But if there's a symbol for multiplying and dividing between the fractions, we don't have to deal with finding common denominators. That is why I would rather multiply fractions or divide fractions all day long than have half a day's worth of adding or subtracting fractions. because you do have to do that step of finding that common denominator before you can begin. Okay? All right. Right here, do we have to change the numbers for multiplying and dividing to improper fractions before we move on? Yeah. When we have a mixed number, we have to change them to improper fractions before we multiply and divide. Do we have to do that for adding and subtracting fractions?
Yeah. I know.
The answer's on the board, right? No is the answer. When you multiply and divide, you must change improper or mixed numbers to improper fractions. For adding and subtracting, what we're doing right now, you do not. Do you have to simplify the result for adding, subtracting, multiplying, and dividing?
Yeah.
Fractions, yes. Always, always, always. That's the only thing you always, always, always do for all four operations, okay? So let me go ahead and back the train up a little bit here. Yesterday we talked about easiest common denominators, right? We filled this one out, didn't we?
Yes.
Okay.
Yes.
Look at your page and make sure you filled it out. Okay. We started right here after we finished our dividing fractions notes. We started right here and we talked about finding the easiest common denominator. And then we filled out this page. We talked about how easiest common denominator, you just swap the bottom two numbers with each other and you multiply the opposite fraction by the other one's denominator. Okay? And then you get your result for your new fraction that you can then add or subtract. All right. And then today I got to telling you that if these two denominators are factors of one another, you only really would have to change one of those fractions to find common denominators. Okay? That's the difference between the easiest common denominator and the least common denominator. That's what I started out talking about today. Okay, but what about mixed numbers? Now I have to back the train up one more. For mixed numbers, did it look like here that I changed those mixed numbers into improper fractions? I did not. Look, I took 2 4/5 plus 1 3/5 and I added those to the 2 and the 1 together. The whole numbers are now added together. Okay? And then I took those two fraction parts and stood them side by side, and guess what I saw? I saw they already had common denominators. Yay! So I knew this was 7/5. Okay? So now I know my fraction is worth 3 7/5. However, is 7/5 an improper fraction? Yes, it is. So I had to take out 5/5 from 7/5. If I take 5/5 out of 7/5, what do I end up with? I end up with 2/5, don't I? So this one set of 5/5, how much is that worth? It's worth the whole number 1, isn't it? 5 divided by 5 is 1. So my answer is 4 2/5. Okay? Now, some of us are ready to move on to this. Some of us are going to be really riding the struggle train today. And I apologize for that, but I want you to work hard on this, all right? Here's another example. For 4 2/3, this is the way I like to set mine up. I do not like to set them up like this, going sideways. I prefer to set them up going this way, okay? 4 2/3, I'm going to use the easiest common denominator method. I'm swapping the 5 here, and I'm multiplying this fraction by 5/5. I'm swapping the 3 here, and I'm multiplying this fraction by 3/3, okay? So my new set of fractions are 4 10/15 and 5 6/15. When I add the whole numbers, I get 9. When I add the fraction part, the numerator part, I get 16/15. Again, I notice here 16/15. Well, one whole set of 15 can fit into 16. So I pull that 15/15 out, which is really worth how much? 1 whole. So my answer would be then 1 and I have an extra 1/15 left over here, don't I? So my answer is 10 1/15. Okay. All right. Are these already filled in on your notes like this?
Yeah.
So you don't have anything to write in on there?
No.
Okay. All right. So now we're going to look at 4 and 5/8. 4 and 5/8, they did not make improper fractions, did they? Yay, they didn't have to do that. They just took those whole numbers away from those fractions and they added them together. And then they noticed, dude, they already have common denominators. Yay! So we have 9/8, don't we? The answer here then from this batch of numbers is 5 and 9/8. But that's the same as saying 5 plus 8/8 plus 1/8, isn't it? So my answer has to be 5 plus 1, and then that leftover 1/8. So my answer is 6 and 1/8. Okay. Do we have any questions about why we're getting these extra ones right here? No? Okay. Here's what you will write on this page. Are you ready? Hey, get your pencils ready. I want you to write some notes down. All right. So I would like you to write a box around each time they ended up with an improper fraction. Okay, so that was the first one. And then we looked at this problem, and this was the next one. Okay. And then in that last problem, where did they end up with the improper fraction? Right here, didn't they? Okay. So here's the big deal I want you to write first. Can you stop clicking your pencil?
Yeah.
Boy, this is hard to write on you guys. I really am not this shaky. Okay. So maybe you want to write that note in the way you want to write it. That's just how I'm going to say it. Improper fractions have whole numbers hidden inside of them that need to be added into the answer at the end. They also need to be taken away from the fraction part. So you could write it two ways, couldn't you? But either way, when you get an answer after adding your fractions together in a mixed number, if your fraction part is an improper fraction, you divide it out, you find out how many sets. And each time, in each of these ones, there was only one set, right, of wholes that needed to be taken out. So we only had to add one each time. Okay. Sometimes if you divide out your improper fraction, you're going to find that you'll get bigger numbers that you have to pull out of there. What if you have an improper fraction and it's so improper that you get 2 1/3? Well, instead of just adding 1 right there, you'd have to add 2 instead of the 1 if your improper fraction has more than one set of holes hiding inside of it. Okay, maybe grab a different color now. Or when you're done writing. Okay. Okay, so the other thing I wanted to talk about when you're adding mixed numbers is Oh, I'm not sure if we wrote this down the other day or not. This is just a side note. Okay, I want that written down. Okay. Okay, I don't remember what that second thing was. I wanted to. I don't have it written on my paper. Nice. Okay. So that's all I need you to write. I lied. So you have this note up here about parentheses and this one about improper fractions. And I know there's something else I wanted to say, but it fell out of my head. So we'll just move forward. Okay, because we know Mrs. Franzen, sometimes she has those problems and she thinks she knows what she's going to say and then she forgets. Okay. All right, 4 1/2 plus 3 1/8. So I'm going to go ahead and change it to 9/2 plus 25/8. That ain't right. Do we have to change our mixed numbers to improper fractions to add and subtract them? Absolutely, tutti frutti not. So don't do that. Don't make an extra step for yourself. Okay, that was my point of putting that in the notes earlier. What you're going to do then is if you're like me, I like to go from top to bottom when I'm thinking math. Sometimes I like to go side to side, but with fractions, I like to go this way. So I have 4 1/2, and I'm adding to it 3 1/8. Okay. Do I have common denominators?
No.
No. So what I should have done was looked at that problem and said, is 2 and 8, are those two numbers compatible? Do they have factors in common? Of course they do. The easiest way to change this fraction is to fix this fraction up so that it is a denominator of 8. So then it would match the other one. So what would I need to multiply by here? Well, 4/4. If I just multiply by 4, that's not going to help me much. I need to multiply by 1, and 4/4 means 1, right? So then I can, instead of writing 4 1/2 over here, I could have wrote what?
8, 9.
4 4/8, because 1 times 4 is 4, 2 times 4 is 8. Now do I have common denominators?
Yes.
I do. Now I can start adding, okay? What is 4 plus 3? Super easy. That's 7. 4 plus 1 is 5. Okay, do I have anything to simplify there? No, there are no improper fractions. So I don't have to worry about dividing it out and adding a 1 to the whole number. Okay, that one was pretty easy. Now I'm going to look at the next one. Does this fraction and this fraction have a common factor?
Yeah, 12.
Well, between the two, they don't have a common factor, but if you multiply them together, then you get 12. That would be actually the least common multiple between those. So that's kind of nice. So here, I'm going to multiply this side by, I'm going to use a different color so that we can see it. So this side, I'm going to multiply over here by 3/3, right? I'm going to put in parentheses. Yeah, I'm writing over the adding sign. Who cares? Who cares? It's okay. Then I'm going to stack it up. I'm going to go 7 and 9, 12. Where'd you get the 9, Mrs. Franzen? Well, I multiplied right here. And I multiplied right there. And then I'm going to get 7, or 2, and 4, 12. Am I adding? Yep. Okay. So then I have 9 and 9 plus 4 here. And I'm done, right?
No.
No, I have an improper fraction right here. So I need to say to myself, well, how many groups of 12 will go into 13? One group of 12 will go into 13. So that's going to give me the whole number 10. And if I take away 12 12s here, how many leftovers do I have? 13 minus 12 is 1, 12. So 10 and 1, 12 is going to be my answer. Okay? Make sure you've got that written down because these are your notes that you need to have examples in. Okay, so I'm going to give you guys a minute to make sure to copy all of that down so that when you get to it, those kinds of questions, you can just go back and think through the way we did just now. And you know, there are a bunch of videos on the internet that explain how to multiply, add, subtract, divide, all kinds of videos. The best ones on the internet I like are the math antics ones. And if I had time in class, I would literally show you every single math antics video for fractions. I would literally do that, but we don't have that kind of time, so I'm not going to. But if you have time at home, invest your time in that. That's really helpful. Instead of doing ticky-talkies and snippy-snaps, you can do math antics. Okay?
I got 100 likes on the video.
Okay, I am unmuted, so you guys are quiet, okay? Are you guys all caught up?
Yeah.
Okay, because I want to erase so I can start this bottom two. Okay. All right, 1 2/3. If I have 1 2/3,
6.
wait a minute. Mrs. Franzen, you're skipping ahead. First of all, concentrate on common denominators. There's a 3 there and there's a 2 there. Neither of them are factors of one another, so we do have to do easiest common denominator, which means we're going to swap from over here, we're going to use this 3/3, and from over here, we're going to use this 2/2, and we're going to redo our fractions then. So I would have 1 4/6 plus 5 3/6. Okay. Now, I've got common denominators. Can I go ahead and add? Yes, I can. 4 plus 3 is 7, 6. I have an improper fraction in my answer, right? Okay, so I've got to fix that. What would I have to do? Well, what is 6 plus 1? 7. And what if I subtract 6/6 from this 7/6? How many leftovers would I have? 7 and 1/6. See what's happening there? Okay. Get that written down.
If we do it in our head, do we have to show our work on our head?
Thank you for answering for me. Okay, so I have 5 and 1/6. Yeah, Jade answered for me. And then I have 5 and 3/6, don't I? Some of us can just see, like Ty said, I know that 6 and 2 are going to be the common denominator of 6, and I know that a common denominator of 6 has to have 3/6, because it's obvious. Half of 6 is 3. Okay, so if you just know that, that's fine, but I'm going to want to see this kind of stuff. All right, I'm ready to add. Add those whole numbers, I get 10. Add those numerators, I get 4. Okay, and then I'm going to mark that wrong. Why is that still wrong? I can simplify 4/6. In other words, that means I can take 4/6 and divide by a common factor of 2, and I get a new answer. I keep the 10, and I just have 2/3 left over. Okay. Okay, it wasn't improper. It was just a matter of that fraction not being its simplest form. Okay. Now I'm going to go ahead and I'm going to hand out the homework. And those of us who are comfortable working on our own, I don't mind. You can work on your own. I don't mind a bit, okay? Because I know all of us are at different levels. So if the teachers want to just hand out the homework assignment now, that would be good. Found it. I got it.
These are.
Okay, I left it unmuted, so be quiet, please. Okay. Okay, I think this is what today's is supposed to look like. Let me double check. Yeehaw, I think it's right. But it's still loading. Here we go. All right. The first three questions are super simple. We're just wanting to recognize the fact that these mixed numbers are hanging out with fractions that are improper. And it's just not cool to hang out with fractions that are improper. Not ever. Okay? So that's what we want you to do, is to recognize the fact that when you have your mixed number answer, we want it to be in simplest form. And simplest forms mean that you have a whole number and then a fraction part that has a smaller numerator than it does denominator. Okay? A smaller top than bottom. And in these three cases, each of the tops, the numerators, are bigger than the bottoms. So for number one, we have what's called 5 and 20/11ths, which in real life is probably not going to happen very often because I rarely ever see in my real life anything with a denominator of 11, but that's okay. We'll just never mind that fact. Okay, so 5 and 20/11ths. 5, you can think of this as 5 plus 20 over 11, right? Now, what if I subtract away from there 11/11ths? I'm taking a whole set of 11 out of the 20/11ths, and what do I get? What's 20 minus 11, in other words? Okay, and what is this number worth here? That's worth a whole. So I really have, what I have now is 5 plus 1 plus 9/11. So I actually have 6 and 9/11, don't I? Okay, that's exactly what you need to do when you come upon an answer that has an improper fraction hanging out with a whole number. Okay, because mixed numbers should be hanging out with fractions, but those fractions really should be regular fractions, simplified. Okay, so what I want to see for that answer for number one is that. And if you just write this there, are you helping yourself for the other two questions? No, I want you to show all the work that I just wrote on the board, because that helps you then see what to do when you're sitting at the kitchen table and your mom says she's never seen this math before and she doesn't know what to do. Then you can say, well, I've written one of them down the way Mrs. Frandsen would like to see it done. Okay. Now, if you have a different way and you get the same result, I know that Mrs. Lewis showed a different way yesterday. That's great. Okay. But have an example written down or two that you understand so that when you go to do more problems, then you know what to do. Here's what I love about this worksheet. So far, I can see that this one, this one, this one, and this one are going to be easy peasy to start out with because they already have the same denominator. Okay? So do we even need to do an example there? No, I'm not going to do an example here because we already have common denominators. Okay? I would like to start with one that doesn't. So I'm going to start with number 8. We'll do that one together in class. Are you ready? Say yes.
Yeah.
Thank you. All right. I'm going to look first at the denominators. Somebody is making notes on the chat, and I have no idea what they say, and I can't look at them. So if another teacher wants to pipe in with those comments, I'd love it. Okay, so 9 and 3. 9 and 3. have a common factor of 3, don't they? So do I have to change both those fractions? Absolutely not. I can keep 5 and 5/9. But on this one, I need to multiply 1/3 by 3/3. So what is 2 and 1/3? And then I multiply that fraction part by 3/3. 2 and 3/9. Very good. Now I've got to remind myself to look at the symbol because these are both adding and subtracting questions on the same worksheet. This is an adding question. What is 5 minus 3 in the numerators? Very good. And then why did I subtract? That is a good question, isn't it? Even when I just told myself that this is an adding problem, I still said subtract, didn't I? Okay, sometimes our brains do that kind of stuff to us. Now, let's look at this answer. Will I mark it wrong or right?
Wrong.
Right.
Right. Yeah, you can't simplify.
I cannot simplify. It is not improper. Everything's golden. Here's my answer for number 8. 7, 8, 9. There's a joke.
Oh.
That's the punchline, right? Yeah. Yes, you may. They're in the usual spot on my desk. Number 8. Okay, is it going to help you to write just 7 and 8/9 for that answer? No, but matter of fact, I'm going to mark it wrong. Okay, so if you have the work written there and you have it all right and you know it's good, then you can go ahead and go on. I'm going to give people who write a little slower than others a little bit more time, and then we're going to flip the page over. Well, you have to hustle, right? Well, okay. Now is when it's hard for me because I'm not sure who all is doing work and who all is copying notes down. So I'm about to start on a new problem on the back side. Is there anybody who wants me to wait a second? Okay, I've got one person in here that wants me to wait a second. So keep on working.
Mrs. Francis, I think we can determine what this worksheet is. Is it?
It should be in their color group. If it is not there, let me know right away. That would be good. Yeah, it might be still in draft form and I forgot to assign it. So let me know. Oh, somebody at home said they looked in the color group. It's not there. I probably still have it as a draft. I'm sorry. I'll get it done right away as soon as I'm done with our last example. Yes.
Why is there only magnifying glass and says LO question 18?
Yeah.
You know, on question 18, I left it out. I didn't like the question. So when I made the Google Slides for these, I left question 18 out. So don't freak out because there's another question missing. It's because I purposely left it out. I don't know. I just wanted you guys to notice, I guess, in case you were numbering things. Oh, and if you do the project, the what did I call them yesterday? Pixel art project for this one, and that should also be on the color group too. If you do the pixel art, you do the same thing. You make the decimal version of the number. So if you have 6 and 9/11, you have to simplify by going 9 divided by 11, and then round that decimal point to its nearest thousand. Yes.
Yeah, so we're gonna see it.
It should.
No, we're gonna see it before we do it.
It shouldn't show up before you do it. It should be blank, and then it will reveal itself. Okay, so I think we're ready now to move on to the other side and do another example before I log off. Okay, all right, let's see here. I see that there's 2 story problems. Story problems sometimes freak kids out. So we're not going to do those as examples, but we'll talk about them before we move on. You just bought a new CD. The first song is 5 3/16 of a minute long. The second song is 4 7/8 of a minute long. How long are the 2 of them together? Okay, what do you suppose we need to do to those 2 mixed numbers? Add them. This puppy is an adding question. Okay, that is our clue, the word together. Okay, number 17. It says, 3 friends went out for ice cream. Ooh, I wish one was me. Okay, I'm going to just change this one to me. All right. And Kara ate 2½ scoops of ice cream. Daniel ate 4 1/4 scoops of ice cream. And Juan ate 3 2/3 cups of ice cream. Well, I want to be Daniel instead because I really like my ice cream. So I'm going to change it. All right. You don't have to do that. I'm just being a doofus. How much ice cream did they eat all together? Well, they probably ate all of it, right? Because I don't know very many kids who are going to get a bucket of ice cream and not eat it all if they have it. You know what I mean? Okay. But still, are we adding then or subtracting? We're adding. All together means that this is an adding question, doesn't it? That is our clue. We have to be little detectives when we read these story problems. All together and together, both are signals that we're adding our numbers together. Got it?
Yes.
Okay. Now let's concentrate on one of the problems above. Let's look at 4 5/8 and 3 2/5. Okay? Now, I know that Miss Lewis used this method called the butterfly method. We talked extensively about doing this butterfly method in my math master's class. Okay? So what we're going to do is we're going to ignore the fact that there's whole numbers there. And we're just going to multiply diagonally. Right? And when we do that, we get 25 up here and 16 there. Trust me, it works. When you start at the bottom and you use the 8 times 2, I get 16, don't I?
Yeah.
And then a 5 times a 5 gives me 25, doesn't it? So what would have been my common denominator? Multiply those 2 together. 24, right?
Yes.
So that means that my number is actually 25 24ths, and then it's 16 24ths. Okay? Why that works? Okay, conceptually, we kind of have to know why that worked. That worked because we did almost the exact same thing. On this side, we multiplied that 5/8 times 5/5, didn't we? Right? So 5 times 5 is 25. 5 times 8 is 24. Okay? And on this side, we multiplied, when we did that diagonal multiplication trick, we multiplied both the top and bottom number by 8/8. And we got 8 times 2, which is 16, and 5 times 8, which is 24. Oh, I thought it was a 3. Okay. Yeah, what would it be then, you guys?
40.
Yeah, I had it covered up with my marker because when I did my butterfly, I couldn't quite see that bottom number. Sorry about that. Sorry, like a Canadian would say, sorry about that. So now I have a subtracting problem that says exactly what it said up here, because I had a 25 up here, didn't I? And then up here I had a 16. See how cool that is? That trick works really well. Okay, so conceptually, that butterfly trick, all it does is the same stuff as multiplying those fractions by the value 1 from the opposite denominator. Okay, so what is 25 minus 16?
9.
It is, yeah, sorry, I wasn't listening. 940 is my answer, yay! But is it? Can we just ignore the fact that we had whole numbers there? No, what is 4 minus 3? 1. So I still have that 1 there. Okay, 1 and 9/40. Okay, I know it's sloppy, sorry. But I just wanted to tell you guys why Miss Lewis's trick works, is because basically you're doing the same thing, but you're using those loops to remind you to use the opposite denominator, multiply that numerator by it, and then find that common denominator. Okay? Thanks, Miss Mueller, for letting me know about my 40. It should have been a 40 instead of a 24. All right, does everybody understand why plus 1 and 1/7 really means? Really means that I'm just taking this value of y, 1 and 5/7, and I'm replacing it with y. And then I can subtract 1 and 5/7 from 1 and 1/7. And this one's easy because it already has common denominators, so my answer is going to be, what's not subtracting, it's adding. What is 1 plus 1?
2.
What is 5 plus 1?
6.
What is our denominator?
7.
Okay. So we do have homework, and yes, there should be a pixel art activity for you to do with the decimal answers that match these mixed numbers. Okay, I will get those up. I know that since they're not there, that they're sitting there in draft form, and I need to push a sign. Sorry about that. Any questions?
No.
Okay, get busy.